Hello and welcome to this special edition dedicated to Math Week. Today we are going to dive into the fascinating world of Tissot indicators. For those who don't know, Tissot indicators are mathematical tools used in cartography to measure geometric distortion and perturbation on a map in relation with the Earth's surface. In this program, we will explore in depth the various applications of these mathematical indicators. We will see how they are used to map out geographical areas accurately today. So sit back and get ready for an exciting journey into the world of Tissot indicators. We met Paul-Amaury de Beson live from Vannes with the Dr. Offredo and the Professor Blanchard.
Yes, hello everyone. I live from the Vannes Mathematics Laboratory with Professor Offredo.
Hello.
And Professor Blanchard.
Hello.
Professor Offredo is a former student of the ENS after completing his prepa at the Alain René Lesage Health School in Vannes. As for him, Professor Blanchard is a former Polytechnic student.
What is Tissot indicator?
The Tissot indicator is a mathematical tool used in cartography to represent the distortion in the projection of spherical surface on a flat plane.
Are all the maps modeled using Tissot indicators?
No, not all maps are modeled using Tissot indicator. The use of a Tissot indicator depends on the purpose of the map and the level of detail required. They are particularly useful for maps that require high level of accuracy, such as topographic maps or maps used for navigation. However, for more general purpose maps, other visualization technique can be used, like the conical projection.
Does this system allow you to model all the maps? And do you think his representation is the most reliable and accurate available to us?
Tissot indicator system is a useful tool for understanding and evaluating distortion in map projection. It doesn't model all map, depending on the need of the map and the purpose of the projection. Different map projection may be more appropriate, each with its own advantage and disadvantage in terms of preserving some geometric properties, such as area, angle or distance.
Can you explain to us how this system works and what are the mathematical tools needed to model Tissot indicators?
Okay, so to begin with, let's define two portions of surface, as you can see here, called small sigma and grand sigma. We will suppose that these representations are bijective. In other words, the function for switching from one coordinate to another coordinate is bijective. We also define two orthogonal frames on each portion, which are respectively A, du and dv, and the same with a majuscule for the other orthogonal frame. Then, by applying some rules of linear modules, we eventually find these equations that governs the coordinates of an ellipse, which is du on m1 squared plus dv on m2 squared, where m1 and m2 are the two principal linear modules. This ellipsis is called the Tissot indicator. It's the image of the cycle of unit radius in the plane tangent to the point 8 of small sigma. That's why the last representations on the globe with cycle was represented by ellipses. All the deformations or alterations introduced by the representations are entirely determined by the only knowledge in size and position of the Tissot indicator. This proposition follows immediately from the definitions of the indicator.
Thank you both for your explanation, which will improve the knowledge of our dear viewer.
Thank you too for the invitation.
Thank you.
Thank you for listening to us. It was the breaking news English. Immediately, 10 of households